In this section, we will find velocity and accelerations for a given position function. If I give you a vector function r ft g of t h of t, means I give you a curve in the space. Okay. Now, if you think about the t is the time, so once you give a t, then you can find ft, g sub t, xt. That means you find x, y, and z. You have a point in the space. Okay. Then you can think about this is the position of the particle. For the different t, then you got a different position. Okay. So we can call, for the motion in the space, you can think about this vector function r sub t is a position function. And if you take derivative of your position function, you got your velocity. And this is equivalent to say, if you know the velocity, then you can find your position function by integrated on both sides plus c. Okay. But remember here, this c here is a vector. And if you take a derivative of a velocity function, you got acceleration. If you know the velocity, then you can integrate it to find your if you know acceleration, you integrate it, you can find your velocity. Let me put it this way. If you integrate both sides of this equation, you're going to find your velocity is equal to the integral of acceleration plus c. I mean, this c is different than the previous c. Okay, this is a vector constant. Okay. Because this is a vector. Okay, vector only add vector. You cannot, like a vector, add scalar. Okay, now let's look at the example. So in this section, basically, what I want you to learn is, for example, position function, you can find velocity, acceleration, and speed. Okay, speed is the magnitude of a velocity. Okay, speed tells you how fast the particle goes, and the velocity gives you more information. Okay, to tell you how fast it goes and which direction it goes. Okay, and on the other hand, I want you to be able to do is, for given acceleration, how can you find the velocity and position function? Now let's see, if I given you position function, which is 3 cosine t I plus 2 sine t j. I want to find velocity, speed, and acceleration at t equal to pi over 3. Okay, now I give you a position function, r of t. I want you to find the velocity, speed, and acceleration. So r of t, if you write in the you can write it this way: 3 cosine t, 2 sine t. I prefer write this way. Again, it's simpler. Okay, first of all, let's find the velocity. Velocity is derivative of your velocity function. Derivative of vector function means you take derivative of each component. So take derivative of first component give you negative 3 sine t. Okay. Then take derivative of second component give you 2 cosine t. Now let's find acceleration first at t. Okay. Acceleration is a derivative of your velocity, which also means second derivative of your position function. Okay, so take derivative of this function, which is velocity. Again, you take derivative of each component, give you negative 3 cosine t and a negative 2 sine t. Okay, now we find the velocity and the acceleration at any moment t. Now, what we want to find is velocity at t equal to pi over 3. So you just need substitute t there by pi over 3. 2 cosine pi over 3. Sine pi over 3 give you square root of 3 over 2. And cosine pi over 3 give you 1/2. So times 1 times 2 give you 1. Okay, what is speed? Speed is the magnitude of your velocity. So speed at t equal to pi over 3 is the magnitude of that. So the square root the first component negative 3 square root of 3 over 2 whole thing square plus 1. So give you 9, 3 square give you 9. Square root of 3 square give you 3. So you got 27 over 2 over 4 plus 1. Okay. So this is 4 over 4. So give you 31 over 4. That's the speed. Okay. Remember, speed is scalar, velocity is a vector. Okay, your acceleration at moment t equal to pi over 3 give you minus 3 minus 3 times, where's my acceleration? Okay, cosine, replace t by pi over 3, then minus 2 sine pi over 3. So you got a minus 3 times 1/2 and minus 2 times square root of 3 over 2. Let's give you acceleration, which is a vector. Okay, now let's look at another example. In this example, we give you acceleration, which is 2ti plus sine tj plus cosine 2tk. And we also know, this means 2t sine t cosine 2t. And we'll also know initial velocity. I mean, initial means t equal to 0. The velocity is I. What that means? That means 1, 0, 0. If you write it as triple. And we know the initial position, okay, which is J, is 0, 1, 0. Now, what do we want to find? We want to find velocity v of t and the position function r of t. That's what we want to find. Okay, we know velocity and acceleration related like this way. Integrate a of t dt plus c. C is the vector. Okay, here is my a. Okay, you integrate a vector means you integrate each component of it. So first component 2t dt, second component integrate that, you got a sine t dt, integrate the third one, you got a cosine 2t dt, then plus c. C there is a vector, say c1, c2, c3. Okay, you integrate the first one, give you t squared. Since we already have c here, so we don't put c here. Okay. Integrate sine t, give you minus cosine t. Integrate the last one, give you 1/2 sine 2t, assuming you know how to integrate this. Plus c1, not plus, okay? This is vector. First component is c1, second component is c2, third component c3. Okay, we can find c1, c2, and c3 by knowing initial velocity. So we substitute t, replace 2 by 0. We know that v0 give you I, which is 1, 0, 0. On the other hand, look at the v of t equal to this. So replace your, on the right hand side, replace your t by 0. You got a 0, cosine 0 is 1, so you got a minus 1, and a 0 again. Then plus c1, c2, and c3. So, solve for c1, c2, and c3, which is equal to 1, 0, 0, subtract 0, minus 1, 0. Therefore, they give you 1 minus 0 give you 1. 0 minus negative 1 give you 1. And 0 minus 0 you got a 0. Okay, the difference of two vectors, that means find vector subtract the vector means you subtract each component. Okay. Therefore, my v of t here is equal to t squared minus cosine t 1/2 sine 2t plus c1, c2, c3, which is 1, 1, and 0. You add those two vectors together, give you t squared plus 1, then 1 minus cosine t. Let's add second component. Third component, 1/2 sine 2t plus 0. That's it. So we find our velocity. Okay, so our velocity is equal to this. Okay, find the velocity, we can find position function. Position function is integral of your velocity, then plus c, which is a vector. So my velocity is like this. So integrate of vector function means you integrate each component of it. Then integrate the second component. Then integrate the third component. Then plus C, which is C1, C2, and C3. Okay, now let's integrate it. So t squared, you integrate it, give you 1/3 t to the third, plus t integrate 1, give you t. Integrate the second component, give you t minus cosine t integrated, give you sine t. The last one you integrated, give you minus 1/4 cosine 2t. Then plus C1, C2, and C3. That's our RT. Okay, we can find C1, C2, C3 by knowing initial position. Initial position, which is replace t by 0, R0, equal to J, which is 0, 1, 0. We know this. But on the right hand side, replace all the t by 0. So the first component, 1/3 times 0 plus 0 give you 0. The second, replace t by 0, and sine 0 is 0, so your second component is 0. The third one, replace t by 0, cosine 0 is 1, so give you minus 1/4, plus C1, C2, C3. So you can solve your C1, C2, C3 by add this vector on both sides of the equation. So you got 1, 0, and subtract 0. Subtract 0, 0, minus 1/4. So they give you 1. 1 minus 0 give you 1. 0 minus 0 give you 0. 0 minus negative 1/4 give you positive 1/4. Okay, therefore, our R of t here is equal to 1/3 t to the third plus t minus sine t minus 1/4 cosine 2t plus C1 is 1, C2 is 0, C3 is 1/4. Add those two vectors together, which means you add each component. So you got 1/3 t squared plus t to the third plus t plus 1. Okay, second component, t minus sine t plus 0. Then you got 1/4 subtract 1/4 cosine 2t. The third one is like add third component together. Okay. So we find RT and V sub t.